Hello everyone and welcome to day 4 radian measure of the trigonometry unit. The one thing that we're going to be doing today is we're not actually going to be starting right at the beginning. We're going to be starting on page 17. The reason being is we're going to work on the idea of radian measure in class, but I want to give you a little basis before we start that in class. So a radian measure is looking at an angle measure, but not in terms of degrees. And that's going to be the hardest thing for you guys to think of, is that radian measure is not in terms of degrees. What we have here is that a radian measure is a measure of any central angle in a circle that intercepts an arc in equal length to the radius of the circle. And this is really key, and you're going to see this and we're going to talk more about it. Again, we're going to talk more about it in class. Hopefully this will give you a basis. Here is the radian measure. Here is your radius. This angle is equal, theta is equal to 1 radian if the arc length is equal to the radius. And that's what it's saying. So see how this arc length right here is equal to that r there? Then we can say that theta equals 1 radian. So let's just look at this, and we're only going to talk about half of it because we'll do the other half in class. If r equals 5, and then s equals 20, or 10, excuse me, 10. So we'll say here's 5 and there's another 5 right there. This entire thing here is 10. What is your theta? Well, there's 5. That's 1 radian. Well, there's another 5 here. That's 1 radian. So now we have theta to equal 2 radians. So again, why is that? If the arc length is double the radius, we know that that's 2 radians if 1 radian is equal to the arc length of 1 radius. What about r equals 8? So the radius being 8 and s being 24. Well, in that case, we're going to have 24 divided by 8 because we want to know how many radians there are, and there's 3. Or in this case, if our radius is 6 and our theta is 21, ooh, something different here. So let's draw this out. If our radius is 6 and our theta equals 2.1, well, there's 1 radian there. That would give you 6. There's another radian here. That would give you 6. And 2.1, so we would need another tenth of a radian right there. Well, we got to figure out what that is. Well, how could you do this? Well, you're going to use the opposite method here than we used above. We said that the arc length here divided by the radius equals 3. So in this case, so again here we did arc length divided by radius equals theta. In this case, what we're going to do is radius times theta. So 6 times 2.1 to give you 12.6, and that's the total length, which makes sense. It's just a little more than 12. 6 plus 6 is 12. Just a little more, 12.6. And so we just answered how are s and theta related. Well, we just talked about that. If the radius and the arc length, we can figure that out as arc length over radius, it's an s, equals theta, then we can also say that radius times theta equals arc length. And if you want to write that down, you can say that arc length equals theta. Or sorry, arc length equals s in this case. Arc length equals s. And so that's how radiuses and radians are related. Let me show you something else here. Here's an example of a radius being 1. So the radius is 1 here. And the arc length being 2, which results in, since the arc length is 2, it's double the radius. Therefore, the radius is 2. The angle measure is 2 radians. Let me show you what happens when I go larger. If I make the radius 1.5, the arc length is now 3 because the radian measure has not changed. This measure has not changed. What if I go to 2? Again, I'm just blowing the circle up, okay? But I'm not changing the radian measure. That's now 4. The arc length is 4. And if I keep going, and you can see what happens here. But what happens if I change the arc length? Maybe I'll change the arc length to right around, and I'll try to make it perfect here, 2.5. Now it's 1 radian. And if I close that, make that a smaller circle, you'll notice that the arc length measure is equal to the radius. What happens if I just kind of go just a little bigger? Right? It all is going to be in proportion. These are all proportions. And therefore, that is why this is a proportion right here. Okay. Let's look at the next page of radian measure, using radian measure. And so we're on page 19. We're going to look at a couple of these problems using the knowledge that we just talked about. Suppose a central angle in a circle with radius of length 5, so we got 5 here, intercepts an arc of length 20. Oh, that's large. What is the measure of the central angle in radians? Well, we kind of know that it's kind of going to go beyond here. So let's just figure out the radians. We know that theta, okay, equals the arc length over the radius. If we have the arc length to be 20 and the radius to be 5, we know that theta then equals 4. Theta equals 4 radians. Meaning that we have actually gone around the circle more than once. And again, we'll talk more about that in class. So look at number 2. Suppose the central angle in a circle with radius 5 intercepts an arc length of 7. Well, that we can actually draw. What is the measure of the central angle? Well, we know if it's 7, we know it's more than 1, but shouldn't it be too much more than 1? So let's look at it. So again, we know theta equals arc length over radius. So we have the radius to be 5. We know the arc length is 7. So theta equals 7 over 5 radians. And that's just a little more than 1. Number 3, and again, at any time when we do these videos, pause this. I know I'm going fast, but just pause it and repeat it. That's the great thing about video. So if I'm going too fast, just pause this and repeat it. 3, a central angle in a circular garden measures 2.5 radians and intercepts an arc of 20 feet. And so therefore we know 2.5 radians, well, that's going to be a good amount. So if we have a radius here, we don't know what that is. And 2.5 radians, we'll say, is about there. Maybe there, more like it. And we have an arc length of 20. What is the radius? Well, we know that this angle is 2.5. So we know theta equals, again, arc length over radius. 2.5 equals 20 over r. And in this case, we'll multiply, cross multiply. So we're going to get 2.5 r equals 20. Divide by 2.5. And so r is going to equal 8 feet. And so that's how we're going to have to look at these. What I would like you guys to do right now is try numbers 4 and 5, please. So we're going to be trying 4 and 5, so pause it and try them. And so for number 4, hopefully you got this answer. And again, you're going to pause this and look at it. The one thing I wanted to go with number 5 is just to look. We have a garage and a fence at a corner. The dog's leash is 20 feet. And so the radius is 20 feet. And when the dog walks from the fence, all the way from the fence, all the way to the garage, he makes a arc length of 55.8 feet. And so therefore, that's why we don't know exactly how much of the circle we have, but we don't have the entire circle, of course. So a garage, a fence, a leash is attached there. When he walks all the way out, it's 20 feet, and then he can make an arc from there. And I'm sure you've seen many of those. So again, pause this, check it, and we're going to go on to page 20. So a lot of the key ideas when you look at these problems is to actually draw it out and figure out what am I looking for. We're going to skip number 6 right now and go right to 7. A wedge-shaped piece is cut from a circular pizza. The radius is 6 inches. So we've got a pizza with a radius of 6 inches. And we want the crust to be 4.2 inches. Now, right away, let's even talk about this. Is this going to be larger or smaller than 1 radian? Is the arc length of 4.2 going to be smaller or larger than 1 radian? And hopefully you're thinking smaller because it's smaller than the radius of 6. To the nearest tenth of an inch, what is the angle at the pointed end of the pizza? We want to know what that angle is. Well, we are looking for the angle, so theta equals the arc length 4.2 over 6. And that'll give us 0.7 radians if you had used your calculator. And so we're going to leave 6 and 8 for class. And again, we're going to look at what radians are a little more in depth in class. So we'll see you in class.